Hello friends, welcome to my channel D square plus D, and I hope that you are enjoying my classes. Today let us learn a new concept, that is elementary operations on matrices or elementary transformations on matrices. There are three properties we need to study under this category. Let us look at these properties one by one. Elementary operations or transformations. The first property, interchange of rows or columns, that is, any two rows or columns of a matrix can be interchanged. Let us see this property by taking an example. We have a 3 by 3 matrix with the entries 0, 6, 5, 2, minus 3, 8 and 1, 4, 7. We apply a transformation or an operation, that is, R1 implies and implied by R2. Now, what do you mean by R1 implies and implied by R2? We interchange the first and second row to get a new matrix, and we see what is the new matrix we get it. The matrix what we got is 2 minus 3, 8, 0, 6, 5, 1, 4, 7, which is entirely different from the given matrix, and the operation what you have applied is R1 implies and implied by R2, that is R1 and R2 are interchanged. Now let us see this property by taking column operations corresponding to that. Let 1 minus 2, 0, 4, 5, 1, 6, 7, 2 be the given matrix. We perform an operation C2 implies and implied by C3. That means C2 and C3 are interchanged, the second column and third column are interchanged, and we get a new matrix, that is 1, 0, minus 2, 4, 1, 5, 6, 2, 7. C2 and C3 are interchanged. We move on to the next property, multiplication of the elements of a row or column by a non-zero real number. That is, any row or column of a matrix can be multiplied by a non-zero real number. We take an example, a 3 by 3 matrix, 1 minus 2, 0, 4, 5, 1, 6, 7, 2. We consider a transformation C1 implies 2 times of C1. That means we are going to get a new matrix in which the elements of the first column are twice the elements of the first column of the given matrix. The first column of the given matrix is 1, 4, 6, whereas the first column of the new matrix is 2, 8, 12, which is twice the elements of the first column of the given matrix. The second and the third column remain unchanged. So we performed an operation C1 implies 2 times of C1. Now we look at the third property, addition to the elements of a row or column, corresponding elements of another row or column multiplied by a non-zero number. We take an example, a 3 by 3 matrix 0, 6, 5, 2, minus 3, 8, 1, 4, 7. We perform an operation, that is R1 implies R1 plus 3 times of R2. What do you mean by R1 plus 3 times of R2? We get a new matrix in which the first row is replaced by first row of the given matrix plus 3 times the elements of the second row of the given matrix. Accordingly, we get first row as 0, 6, 5 plus 3 times of the second row, that is 2 minus 3, 8. On simplification, that is 0 plus 3 times of 2, we get it 6. 6 plus 3 times of minus 3, 6 plus minus 9, so we get minus 3. And 5 plus 3 into 8, that is 5 plus 24, we get 29. That means we are going to get a new matrix in which the first row is 6 minus 3, 29, second row 2 minus 3, 8, and the third row 1, 4, 7. So we got this new matrix with the operation R1 implies R1 plus 3 times of R. Now we move on to another example. Let 1 minus 2, 0, 4, 5, 1, 6, 7, 2 be the given matrix. We perform an operation C1 implies C1 plus 2 times of C2. That means we are going to get a matrix in which the first column is replaced by first column plus 2 times the elements of the second column. Let us see the result. First column, that is 1, 4, 6, plus 2 times of the elements of the second column, that is minus 2, 5, 7. Second and third column remain same. On simplification, we get the first column as minus 3, 14, 20, that is 1 plus 2 times of minus 2, that is minus 3. 4 plus 2 times of 5 is 14. 6 plus 2 times of 7 is 20. And second column and third column remain same. So we get the new matrix minus 3, minus 2, 0, 14, 5, 1, 20, 7, 2. With the column operation, C1 implies C1 plus 2 times of C2. Now we look at a few more examples. Let 2 minus 3, 4, 1 be the given 2 by 2 matrix. We consider an operation C2 implies minus 3 times of C2. We get the matrix C1 is 2 and 4 itself. So the second column we are going to change it, that is minus 3 times of the elements of the second column. So if we multiply by minus 3, we get minus 3 times of minus 3, that is 9. Minus 3 times of 1, so it is minus 3. So we get a new matrix 2, 9, 4, minus 3 with the operation C2 implies minus 3 times of C2. We look at the same example 2 minus 3, 4, 1 with a different operation. The operation is R2 implies R2 plus 2 times of R1. That means we are going to get a matrix in which R1 is not changed. What is R1? 2, then minus 3. We need to change R2 as, say, let us take first element of R2, that is 4. That 4 becomes R2 plus, that is 4 plus 2 times of corresponding R1, that is 2. So this is 2 into 2, 4 plus 4. So we need to write 8. Similarly, the second element is 1. That will be changed as 1 plus 2 times of minus 3. R2 plus 2 times of R1. On simplification, 2 into minus 3, that is minus 6 plus 1, we get minus 5. So we get a matrix 2 minus 3, 8 minus 5 from the given matrix 2 minus 3, 4, 1 with the operation R2 implies R2 plus 2 times of R1. So these are the few examples we have considered. I hope you will be able to do few more problems. Let us summarize these properties once again. The first one, interchange of rows or columns. Second, multiplication of the elements of a row or column by a non-zero real number. Third one, addition to the elements of a row or column corresponding elements of neither row or column multiplied by a non-zero number. These properties can be used to find the inverse of a matrix. Thanks for listening to my class. We meet again with a new concept. Thank you very much.